Thank you guys for coming. So today we have Cruz from Truffle Suite to give us a presentation on, using their platform to deploy smart contracts and stuff. So he'll first give a quick overview of, Truffle and the different services they provide, and then go through a live demo of, a TZIP12 Tezos smart contract and deploying that onto the blockchain. So yeah, Cruz, take it away. Thanks.
All right, thanks. Hey everyone, thanks for coming from our workshop. My name is Cruz Molina. I'm a dev with Truffle Suite, and I'm going to be going over the Tezos integration work that I've been a part of with Truffle. So a crash course, if you will, in Tezos smart contract development with Truffle. Before we dive into that and a live demo, I'll just be doing an introduction into the Truffle Suite at large. Then I'll do a specific overview of the Tezos integration so far. We are currently in phase 2 of Tezos integration into our tooling. And then from there, we'll get into the nitty-gritty. I'll be doing a Truffle CLI crash course, going over some key Truffle features as it pertains to Tezos smart contract development. So taking a look at boxes, which are sort of our templates, boilerplate for quick start smart contract development, compiling your smart contracts, and then deploying and testing them. So the Truffle Suite, our mission is to get developers from idea to dApp as comfortably as possible. We do that with a range of different tools and components. We have the Truffle CLI, which is sort of the backend tool for compiling, migrating, testing smart contracts. We also have Ganache, which is like a personal blockchain simulator. And then we have Drizzle, which is sort of the front end component of the Truffle Suite tooling. And so these all play different roles in the dApp development lifecycle, and that's how we have fine-tuned and developed these tools to work. Our tooling is 100% free and open source, hosted on GitHub, and currently we have over 3 million aggregate downloads. And so just to sort of put that into context of the amount of usage and the popularity of Truffle and the tooling, we have a wide variety of partners and companies that we work with, whether it's big enterprises like Microsoft and EY, or smaller blockchain startups like Colony and TrailofBits. So sort of the proof is in the pudding, basically. Like people love Truffle. It helps them get up to speed and iterate and prototype quickly. So really great resource that hopefully you can use in the hackathon very soon. And so Truffle, the Truffle CLI, just to do a very high level overview, it's written for Node.js. It dramatically reduces the complexity of building dApps, just making it very easy with this list of commands to compile, migrate, and test your smart contracts. For the Tezos integration, currently we're at version 5.3.0, and that's available at the Truffle at Tezos disk tag. I'll go over that in a minute. So Truffle in use, you install Truffle, the CLI, using npm. And here's just a couple examples of the various key commands. Truffle init, which gets you set up with initial boilerplate Truffle project setup. Also, there's Truffle compile for compiling your smart contracts, migrate, test, and then an unbox command for pulling down other people's boilerplate or Truffle projects that they may have hosted themselves. And then just to go over Ganache, currently, actually, we're as part of phase 2 for the Tezos integration work, we are working on getting Ganache to support and integrate with Tezos. Sort of the high level of Ganache is it's a personal blockchain for blockchain development. It creates a local network for your development, for your testing. There's a couple flavors of Ganache. There's the CLI, and there's also a UI-based version. And so here's sort of the example of the UI. Currently the UI, Ganache UI only works for Ethereum, but hopefully maybe down the road, we can also get that the UI integrated to work with the Tezos blockchain. And then just to go over Drizzle, it's a React JS library for building web views for dApps. The goal being to abstract and reduce the amount of code that you need when working with provider APIs. So in the Ethereum world, that's Web3.js, and the Tezos world, it's something like Taquito.js. Although of course, as with all abstractions, like it trades off some of the flexibility for making your life as a developer easier. And so the main high level takeaway from Drizzle is that it handles the synchronization of your contract and transaction data to a local Redux store. And then, unfortunately, currently for Drizzle, it only works for Ethereum. But again, this may be something that hopefully we can adapt for Tezos smart contract development. And so just going into the integration so far with Tezos, sort of the high level, as it pertains to the Truffle CLI, currently we have LEGO support. So here's some screenshot examples of, we have a counter legal contract example, which I believe is on the main page, the home page for LEGO. And then sort of just, an example of the output when you run Truffle compile against your legal contracts. We also have the ability to migrate to multiple Tezos networks, whether that's a local sandbox network or a test net or even the main net. And so this is, a screenshot example of what that looks like when you're running the command and the type of information that Truffle provides for you while your contracts are being deployed. And I'll show that in a minute with the demo. And then there's also Truffle console, which pops, it connects you to a network and sets you up with a interactive console, an interactive REPL console. And so here's an example of you've deployed your counter contract and you want to interact with it. So we have a contract abstraction that allows you to take your compiled, the stored record of your compiled contract and interact with it. So we have like counter.deployed, which grabs your contract instance from the network, and then you can make calls to entry points. So, increment 5, increment 7, and then also retrieve the storage state of your contract. And so some of the key ideas in general of the integration so far with Truffle is we try as much as possible to expose interfaces and abstractions to match the high level language of LEGO. And we err on the side of hiding low level details by default in order to make the developer experience better, easier, more enjoyable. And in doing so, we handle for the user persisting relevant project information, so the source code, the target, any metadata that's related to the contracts that you're compiling, that you're working with. And then we also, using a Truffle configuration file, we allow you to set up your project to work for various use cases. And then, of course, we just as what we've done for Ethereum, we are trying to provide that same nice developer user experience regardless. So not trying to privilege one or the other, just providing that same experience regardless of which blockchain you're working with. All right, so diving into the crash course. So the prereqs for working with the current Truffle Tezos integration is you're going to need Node.js. I'd recommend 10x LTS. You're also going to need familiarity with Ligo, which is the high-level Michelson-targeted smart contract language. You'll need NPM, the node package manager. You'll also need Docker, which gets used sort of in the background for LIGO compilations and running a local sandbox Tezos node. And then, of course, you'll need Truffle installed globally using NPM. So before we dive into that, I'll just go ahead and do that, pull down Truffle at Tezos. While we wait to do that, I'll just go over Truffle, the most basic of commands basically with Truffle. Truffle init, which will set up your Truffle project in the directory you want to work with. So let's see, installed. So we'll make a Truffle Hello World project, CD into that, and then run Truffle init. So now basic scaffolding is being downloaded and unboxed. And so here you've got, this is the basic Truffle project structure. You have your contracts folder, your migrations folder, scripts, a test folder, your package, JSON package lock, and a Truffle config. So just going over these one by one, every Truffle project typically has a migrations contract, and what this basically is an on-chain counter for your smart contract project. So when you migrate, the scripts that you've migrated will be counted and stored, and so it makes it so that if you run Truffle migrate twice, you won't redeploy contracts you've already deployed. So it's basically, like a simple little helper, an on-chain counter. And then you've got your migrations folder. And this is where, when you're running Truffle migrate, Truffle looks into your migrations folder for these scripts and will fire these off when deploying. And this is the basic initial migration script. And so what we have is some artifacts.require syntax, which is like, it's Truffle specific, and it works around nodes require statements. So here, when running a migration, Truffle will compile your migrations contract, store it in a build folder, and then when you go to deploy your contracts, Truffle will go and look into that build folder, grab the data it needs, returns a contract instance, and then from here, we also have a deployer syntax for then deploying that contract instance that's been loaded. So here it's just this, what the deployer syntax does, or the class does, is here we're deploying just one contract, the migrations contract, and we're also setting that initial state. So we're saying, the last completed migration is 0 because it's it's a fresh new migration, and the owner of this contract is the first account. And then well, tests, we don't have any tests in here. But just to, just to go over the scripts that we have. So these scripts are set up to provide you a ready-made sandbox network for local Tezos development. And so the way, like as it's displayed down here, the way you would start your sandbox is by running npm run start sandbox. And so that command, it calls a start sandbox script and then waits for your sandbox to be ready for deployment. So just to run through that, we'll do npm run start sandbox. And so we'll start up a Docker container of Flex Tessa in the background. We'll then wait for this sandbox network to be ready. We have some retry polling logic. Basically polls the network until it's ready. And the sandbox network is ready. And then the last crucial part of a Truffle project is your Truffle config. So here, in the basic scaffolding, we provide various networks already pre-configured for you. So in the sandbox that gets run and started, there's automatically 2 accounts, Alice and Bob, that are set up out of the box. We store Alice and Bob's information as constants in this file. So we have the public key, which is the address, and then secret key and private key there. And then we have that set up for development. So this, the local host is where your sandbox is running with the port 8732 exposed. And so when you run Truffle migrate, let's just run it. It should be, yeah. Truffle knows to look into the config. It understands when you're running Truffle migrate just by itself, it looks into the development field in your Truffle config, and it uses all this information that's been loaded to then migrate your contracts. And then here, we have various testnet configurations set up for you. So you could also feasibly, here, I'll show you in a minute once the migration's completed. Could also do Truffle migrate -- network and then specify a network that you want to deploy to. Here we're using the SmartPy public node. Oh, that doesn't. Oh, that's right. So I'd need to use any of these public networks, you need a faucet account configured. And to do that, you would go to there's a website. I think it's probably linked on the Tezos dev website, where you would then go and download that the faucet JSON, save it, and then require and hook it up in your Truffle config. Actually, let's go and do that. Just so you can see how that would work. So we have that in some of our documentation. So you'd go to faucet.tzalpha.net, you download the faucet JSON, you pull it in into your Truffle config, and then pass the secret, mnemonic, password, and email, and should be able to deploy. Let's just go ahead and do that. Copy this. And then let's see if I just copy paste. Let's hook it up to the Carthage network. Secret. Password. Email. All right, now, let's see if this works. So we're waiting for this to work. So as you'll notice here, the contract artifacts for migrations has already been stored. So Truffle knows like, okay, we don't need to recompile that again. So here's just sort of a sneak peek into this, the relevant metadata that Truffle stores and uses while running migrations, also while testing. We'll store contract name, we'll store the Mickelson that gets compiled from LIGO to Mickelson. We also store the source code, the path, what kind of compiler was used, which version, and then also the relevant networks that have been deployed to. So currently we're attempting to deploy the Carthage net. You can see that there's some polling logic going down below while we wait for, Truffle polls the network using Taquito under the hood to wait for confirmation that our contract actually got onto the network. All right, and there we go. So just to, go over this output a little bit. We try to provide as much helpful information as possible, while you're developing and testing your smart contracts. So we showed the amount of blocks that were baked, were mined from the initial deployment. Also the contract address, the block number that your contract should be stored at, timestamp, what account was used to deploy that contract, the remaining balance of in Tezos that a given account has, gas use, storage use, the feet spent, the burn cost, etc. And then at the end, we try to provide the total cost that was spent to deploy this a given contract. And then at the end, we'll total up the costs and show you the final cost. Great, so that's pretty much the basic, the bare bones Truffle project setup. So now that we've got that down, let's jump into the good stuff, the TZIP12 token box example. So for this example, we're going to use Truffle Unbox. And let me CD out of here. Let's just get rid of the Truffle Hello World directory. We'll make a new directory, Tezos tzip 12 tutorial, and let's cd over into that. And then we'll run truffle unbox Tezos tzip 12. And we have this box up and hosted, so you should be able to also locally run that command and pull down the tzip tutorial. We'll just verify, yep, the contents are there. I went over this. So yeah, also just as with the Truffle init basic project setup, the tzip box also includes a ready-made sandbox setup. So yeah, as I went over, that'll start a local private sandbox network. It's completely local, it doesn't interact with the main Tezos network. And then yes, on every startup, 2 accounts are currently configured to be unlocked and used. And then, let's see, yeah, I already went over some of those basic commands, but before I do the same here, we'll just take a look at, okay, so, what contracts do we have for the tzip 12? And so, of course, we have our migrations contract, but we also have like the tzip 12 contract, the token. And so, it's got our main function. We have some partials where we're storing some of the legal actions, just a transfer entry point. We also have our storage and transfer partials. So some basic types of, the token owner, token balances, storage, and then sort of the meat of the functionality is our transfer function, which it makes sure that you can only transfer your own tokens, and also make sure that you can only transfer if the sender has sufficient balance. And then when you're deploying your tzip 12 token contract, which I'll show you in the migrations contract, the initial state gets set. So let's go over to migration script. So here, we're requiring the tutorial contract, and we're defining our initial storage to be that Alice has 10 tokens. So 10 tzip 12 tokens. And when we deploy our contract, we set that initial state. And we could expand this to also give, Bob a certain amount of tokens. And, if we unlocked other accounts or had other accounts set up, just do the same from there. To scratch the surface a little bit. So what we also use is to make it easier to set the initial storage. We use a Nicholson mapping helper from Taquito to convert this object literal into an initial storage that we can pass to a contract. And so, yeah, one last step. We'll go over the tests as well. So here in our test file for the tzip 12, you can sort of see a little bit more how to interact with your token contract. So the testing framework it's powered by Mocha.js, if you're familiar with that. And so we have some contract syntax. So it's for this given contract. And then we have before statements, also its statements here. So when running truffle test, we'll migrate the contracts. Here we get the deployed instance of that tzip12. And we also grab that storage just to make sure that it's there. And we also set it in our storage variable. And then our first test case, we'll check and verify, like, is this initial storage actually set for Alice? So we'll get the deployed balance from Alice, and we'll assert that, okay, the expected balance is the same as what's been deployed. And then we also do a test here to make sure that there's nothing that's been stored for Bob. So we'll attempt to grab this storage from the contract using Bob's public key, and we'll assert that actually there's nothing there. And if that's true, then the test should pass. And then here, it's just a simple test case for transferring one token from Alice to Bob. So here's how we format the transfer parameters that we pass using the transfer entry point on the tzip12. And we'll wait for that to happen. We'll get the storage, again, using Bob's private key. And we'll assert that, in fact, Bob has been transferred one token. And then we also do here's another test for just making sure that a transfer from an address that did not sign the transaction is failed. And then one more test that asserts that, well, we shouldn't be able to transfer tokens from Alice to Bob when her balance is sufficient. So notice here we attempt to send 100 tokens from Alice's account to Bob's. And at this point in the test run, she should only have 9. So we should be able to try catch and assert that it failed. So first, do we have, yes, the sandbox should be up and running since we already ran npm run start box. And let's just make sure that our contracts are valid and are able to migrate to the sandbox. So we'll just run truffle migrate. So here we're running that migration tutorial script. And our contract's been deployed. Now let's run truffle test. And this will take a little bit longer because what Truffle does under the hood to make sure that you have a clean state environment is that even though we just ran truffle migrate and we already deployed our tzip12 token contract, Truffle makes sure to remigrate again. So your testing environment has a clean, starts off with a clean slate. And there we go. Our tests pass. Our assertions were true. And that's sort of the overview of what we have here so far in the tutorial. Oh, one thing to note is, since we do use partials in this truffle contract, to make sure that LEGO, like noticing we're using the entry point main, to make sure that LEGO does not try to recompile contracts in the partials folder, we specifically define the contracts directory in our Truffle config to be just contracts/main, not partials. And so in that manner, we make sure that we only compile what's in the main folder, and Alego knows to also include these partials. Yeah. Let's see. Yeah, that's kind of, yeah. That's the walkthrough, the run through of the TZIP 12. Huge shout outs to Stove Labs, Taquito, Alego, Flex Testa, which is the sandbox that we actually use under the hood. And of course, TQ and Tezos Foundation. You know, please, get started, hack on the, hack with the integration, find the bugs, give us some feedback, help us make the integration we have so far better.
Awesome. Thanks a lot for the overview. This is super helpful. I guess we can hop into Q&A if anyone has any questions throughout this process. Yeah, if you have any questions, just toss it into the chat or the Q&A section. No questions? Cool. So in case since nobody has any questions, we can go ahead and end the workshop. So this workshop will be uploaded to YouTube as usual. And if you have any questions following up with regards to anything that was part of the content of this workshop, feel free to toss it into the Discord channel, and we can get those questions answered. Thank you again for your time, Cruz. And next week, there will be a team building session. Hopefully on Thursday. I'll send out an email about it soon. But otherwise, yeah, thank you guys for coming, and happy hacking. Bye.